At the end of this video, you should be able to discuss the relationship between earthquakes and tsunamis, describe 2 possible effects of a major earthquake on buildings, list 3 safety techniques to prevent injury caused by earthquake activity, and identify 4 methods scientists use to forecast earthquake risks. Chapter 12, Section 3, Earthquakes and Society. Movements of the ground during an earthquake seldom directly cause many deaths or injuries. Instead, most injuries result from the collapse of buildings or other structures, or from falling objects and flying glass. Other dangers include landslides, fires, explosions caused by broken electric and gas lines, and floodwaters released from collapsing dams. Tsunamis. An earthquake whose epicenter is on the ocean floor may cause a giant ocean wave called a tsunami, which may cause serious destruction if it crashes into land. A tsunami may begin to form when a sudden drop or rise in the ocean floor occurs because of a faulting associated with underwater earthquakes. The drop or rise of the ocean floor causes a large mass of seawater to also drop or rise. This mass of water moves up and down as it adjusts to the change in sea level. This movement sets into motion a series of long, low waves that increase in height as they near the shore. These waves are tsunamis. A tsunami may also be triggered by an underwater landslide caused by an earthquake. Destruction to buildings and property. Most buildings are not designed to withstand the swaying motion caused by earthquakes. Buildings whose walls are weak may collapse completely. Very tall buildings may sway so violently that they tip over and fall onto lower neighboring structures, as is shown on the screen here. The type of ground beneath a building can also affect the way in which a building responds to seismic waves. A building constructed on loose soil and rock is much more likely to be damaged during an earthquake than a building constructed on solid ground. During an earthquake, the loose soil and rock can vibrate like jelly. Buildings constructed on top of this kind of ground experience exaggerated motion and sway violently. Earthquake safety. A destructive earthquake may take place in any region of the United States. However, destructive earthquakes are more likely to occur in certain geographic areas, such as California or Alaska. People who live near active faults should be ready to follow a few simple earthquake safety rules. These safety rules may help prevent death, injury, and property damage. Before an earthquake. Before an earthquake occurs, be prepared. Keep on hand a supply of canned food, bottled water, flashlights, battery, and a portable radio. Some safety materials, shown on the screen here, can help you plan what you will do if the earthquake strikes while you are at home, in school, or in a car. Discuss these plans with your family. Learn how to turn off the gas, water, and electricity in your home. During an earthquake. When an earthquake occurs, stay calm. During the few seconds between tremors, you can move to a safer position. If you are indoors, protect yourself from falling debris by standing in a doorway or crouching under a desk or table. Stay away from windows, heavy furniture, and other objects that might topple over. If you are in a school, follow the instructions given by your teacher or principal. If you're in a car, stop in a place that is away from tall buildings, tunnels, power lines, or bridges. Then remain in the car until the tremors cease. After an earthquake. After an earthquake, be cautious. Check for fire and other hazards. Always wear shoes when walking near broken glass, and avoid downed power lines and objects touched by downed power lines. Earthquake warnings and forecasts. Humans have long dreamed of being able to predict earthquakes. Accurate earthquake predictions can help prevent injuries and deaths that result from earthquakes. Today, scientists study past earthquakes to predict where future earthquakes are most likely to occur. Using records of past earthquakes, scientists can make approximate forecasts of future earthquake risks. However, there is no currently reliable way to predict exactly when or where an earthquake will occur. Even the best forecasts may be off by several years. To make forecasts that are more accurate, scientists are trying to detect changes in Earth's crust that can signal an earthquake. Faults near many populated areas have been located and mapped. Instruments placed along these faults measure small changes in rock movement around the faults and can detect an increase in stress. Currently, however, these methods cannot provide reliable or accurate predictions of earthquakes. Seismic gaps. Scientists have identified zones of low earthquake activity, or seismic gaps, along some faults. A seismic gap is an area along a fault where relatively few earthquakes have occurred recently, but where strong earthquakes have occurred in the past. Some scientists think that seismic gaps are likely locations of future earthquakes. Several gaps that exist along the San Andreas Fault Zone may be sites of major earthquakes in the future. One of these locations, Loma Prieta, California, is shown on the screen here.
Along some active faults, scientists have identified zones where relatively little fault motion has occurred. These are called seismic gaps. Several gaps exist along the San Andreas Fault, shown in red, which runs along the coast of California. This diagram shows a cross-section of the San Andreas Fault running through the San Francisco Bay Area. Notice the relatively fewer number of earthquakes that occurred in the area of the seismic gap near Santa Cruz. The strain in the rock surrounding the fault line in this area had increased prior to 1989. Seismologists used the gap hypothesis to forecast the approximate time, strength, and location of the 1989 Loma Prieta earthquake in the San Francisco Bay Area. This earthquake and its aftershocks are shown in red.
Foreshocks. Some earthquakes are preceded by little earthquakes called foreshocks. Foreshocks can precede an earthquake by a few seconds or a few weeks. In 1975, geophysicists in China recorded foreshocks near the city of Haizhang, which had a history of earthquakes. The city was evacuated the day before a major earthquake. The earthquake caused widespread destruction, but few lives were lost thanks to the warning. However, the Haizhang earthquake is the only example of a successful prediction made using this method. Changes in rocks. Scientists use a variety of sensors to detect slight tilting of the ground and to identify the strain and cracks in rocks caused by the stress that builds up in fault zones. When these cracks in the rock are filled with water, the magnetic and electrical properties of the rocks may change. Scientists also monitor natural gas seepage from rocks that are strained or fractured from seismic activity. Scientists hope that they will one day be able to use these signals to predict earthquakes. Reliability of earthquake forecasts. Unfortunately, not all earthquakes have foreshocks or other precursors. Earthquake prediction is mostly unreliable. However, scientists have been able to determine areas that have a high earthquake hazard level, as is shown on the screen here. Scientists continue to study seismic activity so that they may one day be able to make accurate forecasts and save more lives. At this point, you should be able to discuss the relationship between earthquakes and tsunamis, describe 2 possible effects of a major earthquake on buildings, list 3 safety techniques to prevent injury caused by earthquake activity, and identify 4 methods scientists use to forecast earthquake risks.